So it's interesting that I've been getting a lot of Bose equipment. I'm not sure why that is, but it's interesting stuff to work on, and fortunately I've been able to get schematics and other information on them. So happy to do it. It's an L1 Model 2. It's got the base, but it has legs that extend out. It comes with a subwoofer and a stick that stacks up. So in part one, I worked on the first of two of these Bose portable PA systems. There was actually quite a lot of time spent on the gathering information. I spent time online looking for schematics and other resource materials. There were some operations manuals, there's some technical manuals, there were parts lists, and so on. And so actually that was quite fortunate. I didn't have too much trouble finding that kind of information. Then I spent some time doing some initial testing with the unit connected up but not taken apart. I then took the thing apart and spent time just learning what was in there and what boards did what, and testing it further and troubleshooting it. It proved to be a very challenging and complex system. I hadn't worked very much on PAs that used a lot of digital signal processing or used pulse width modulation Class D amplifiers in their output. And not only that, I hadn't seen many of the various fault circuits that were actually used on them. And in the end, I had to admit defeat and decided that I would give that particular unit back to the customer. Fortunately, Bose has quite a good return and repair policy where they will take in your unit and repair it for a fixed price, and it's a pretty reasonable price, which includes the shipping back and forth. So this is what we decided to do. So after doing all of that, I decided to move to the second of the two and hope that I would have better success. So this video basically is going to look at that, and in a few places I may refer back to some of the research I did, but it's probably best if you look at that first one to see some of the information about the schematics, the circuitry, some of my analysis of how it worked, which is admittedly incomplete. And fortunately, I had better success with this one, and I'm going to show you what I did and the results that we got. So this has been an interesting project. Within a day or so after I got the first PA in for repair, I got a second one in, identical, with a somewhat similar problem. So I did some troubleshooting on the first one, found some problems, caused some problems, fixed the problems I caused, and had to order some parts. And from there, I set that aside and took a look at the second one, and this is the second one that I got in. And it was doing a very similar thing. When you powered it up, it would run for a little while, and then it would start cutting in and out. The red fault light would come on. I did a lot of analysis on the circuit and found that these units, they have several different kinds of fault detection, and when they detect a fault, they will actually shut the thing down so that there's no damage, and that will disable the outputs and so on. In this case, with the audio signal on the input, you could hear the audio on the output for a few seconds, then it would cut out, it would stay off for a few seconds, then it would turn back on, and off, and on. So I'm going to try and provide a little bit more of an explanation of how this all works. These schematics here are the schematics for the amp modules, and you'll see over here on the left side is where the analog signal comes into that. There's some op amps and just some impedance matching kind of circuits there that allow the signal to be brought in and sent over to these chips on the right hand side. Now this is a chipset that works together. They're the chipset that does the pulse width modulation. It's basically a Class D amp, and the audio signal comes into that left-hand chip. It's converted into a pulse width modulated signal, which is then sent over to the driver chips on the right-hand side. Now those drivers, they are driving MOSFETs. It's kind of like a push-pull stage, I guess you could say, so that they're connected to plus minus 40 volt supplies, and it sends the signal out to the speaker on the right-hand side. The two different output sections there, one is a push while the other one's the pull. Now there's some additional circuitry in here for these fault systems that I was talking about before. So this part right here is called the Zobel protection circuit, and what it does is it's made to equalize, I guess you could say, the impedance so that you don't get a lot of high frequency current flowing into the speakers, which could damage them. And the current is shunted from these high frequencies down through those capacitors to ground. Down at R41 there's a 4.7 ohm resistor, and it's a 5-watt resistor, and the voltage across that is sensed and sent back to that input chip to do with the pulse width modulation. And if the voltage across that rises too high, it says that we're going into kind of a fault condition, and it tells that chip to disable the signal in the front end of the whole circuit, and you don't get any audio coming through. So in the end, it kind of proved to be the source of the problem, but I'll get to that a little bit more later. This is where the signal is fed back to that pulse width modulation chip, and it goes into the Zobel Sense input. And there's one for each side, one for the top MOSFETs and one for the bottom MOSFETs. These outputs on the bottom of that chip, you'll notice there's an OC output for overcurrent, there's an enable output, and there's a thermal output. And on the left corner of the screen there, you'll see a PTC thermistor, and that's one of the thermal cutouts. There's also another thermal cutout up on the right-hand top side of the screen. And I don't totally understand all the functionality of that. The diodes that you see surrounding the driver chips have to do with overcurrent sensing. And the explanation of how that works is very complicated, and I was never able to come up with a good way to test it. But fortunately, that didn't prove to be the problem, and so we didn't have to pursue that too much further. So at this point in the process, I was pretty sure that something was causing the system to go into a fault and then come out of fault and go back in. And I also just didn't know what was causing the problem. I still suspected we maybe had a problem with a power supply somewhere. So I decided to test the voltages on the various power supplies. So to just quickly review the power supplies that are in there, basically it's a switch mode power supply, and I knew that the front end of the power supply was working because I was getting some of the voltages on the output. And there's several DC outputs. So at the top there were two power supplies that were called VDD and VSS, and those were basically 5-volt and minus 5-volt power supplies. They used monolithic regulators in there. Below them in the schematic there was another two power supplies, VD and VS, and those were plus minus 40-volt supplies, and were used in some of the analog circuits in the front end. Then below that, there was also a 10-volt power supply that is sort of an old-style series pass voltage regulator. And that one was where some of my problems showed up in the first Bose PA I had worked on, although that didn't prove to be the ultimate source of the problem. And very challenging to change the parts in that part. So I checked that as well. Those ones were called V drive 1 and V drive 2. And then finally there was another power supply that was called plus 18 volts, minus 18 volts, and those again were used on the front end board. I was familiar with those supplies from having looked at them working on the previous Bose PA. So I started taking a look in that direction, and as I was measuring voltages, I actually found that the voltages were good on all the ones that I could get to. These are very difficult boards to measure because they are partially through-hole construction and partially surface mount. And the surface mount parts are very small. And so you have to be very careful when you're measuring. And it's also hard to find the right test points. But I was able to do that, and found that all the power supplies were okay. But what I did notice in the process was that some of the components were getting a little warm. There were some chokes that I identified as being in the output to the speakers that were actually getting significantly warm. I used an infrared measurement gun to test that, and found that one in particular was warming up. I don't have any video of that, unfortunately, at this point, but it was a clue that led me in the right direction, and that eventually took me to the point where I started looking at those Zobel resistors and found that one of those Zobel resistors had actually opened up. It was a 4.7 ohm 5 watt resistor, but it was now an open circuit. So I didn't have the same package style. This is a radial package style, but I did have an axial package style, and so I put it in, it's right here, to test to see if it would work, and that brought back this particular amp so that it was actually working. And that was this amp right here, the amp that drives the subwoofer. This amp over here drives the column. And so once I put in that resistor, the fault circuit seemed to be working at least for a while when you first turn it on. I was able to put in a signal and get a signal out, a sound out of the sub down here. And I was also able to get a signal out of the column. But after a few minutes, it started cutting out again. And one of the things I noticed when I was doing that was that the volume control pot on the front of the panel, which is down under here, was very scratchy. It seemed to be almost intermittent. It was, as you turned it, you would get thumping in the subwoofer. So I'm not sure if that's a cause of a problem, but definitely that pot needs to be cleaned up first before I proceed. So I'm taking this apart now to get in there so that I can clean up that pot. I don't know if I can get any spray down in there. It sure seems like it was intermittent. I highly doubt that a dirty pot is the true source of the problem, but it's worth cleaning it up anyways to start. So a quick test of that, a quick test appears to indicate that it still has a problem, but that pot is cleaner and seems to be not causing a crackling or a thumping in the output. So we're making progress, but we're not there yet. I finally did get that resistor in that I needed. This was the original one that was open. So this was the resistor I had in there, and I had put heat shrink on the leads and wired it in there, soldered it in. And even though that should have solved the problem, the unit was still cutting in and out. I decided I better get the right resistor anyways, so I ordered one up, got it in overnight, and put it in there, soldered it in, and surprisingly enough, that appears to have fixed the problem. I put a signal on, increased the input levels, tried to get it to fail, and so far it has not failed, so I'm extremely happy about that. What I'm doing now is I'm just putting it back together step by step. Well, I'm very happy to say that the second of these two Bose L1 Series 2 portable PAs is now working. I've got it all put back together, everything's bundled up, and both the main speaker and the sub are working, it looks like just fine. In the end, the problem on this particular unit was simply this little 5 watt 4.7 ohm resistor, and I had substituted a different package style in there to try and get it working. It appears to me that what was happening was when I used this resistor, the long leads were causing an oscillation in the circuit, and when I got rid of that, put in the correct resistor, that seemed to cure the problem. Now, I probably can't explain it any better than that because I'm not sure I understand it any better than that. So I was fortunate to be able to get this one working. I tried to apply some knowledge and good troubleshooting skills in the process of doing that, and I think that did pay off, but really the problem was not an extreme problem. It was one component. So this is ready to go. So I thank you for tuning in on this. I'd be interested in hearing your comments or if you have any knowledge or suggestions about this. So that's it for me today. We'll see you on the next one.
Bye.